First, we need to write the given. Givens are the height of 8 meters and the initial velocity of 10 meter per second. Then we need to illustrate the problem. Should put the height, then draw the building and the girl. Then we need to show the trajectory of the projectile. We need to put the initial velocity. So in this problem, we need to find how far the rock from the house. How far is the rock from the house? Then we need to compute to get the distance of the thrown object. We need to get the time first. Time the object is in the air. We need to use the formula of y is equals to y sub 0 plus initial velocity of y times t plus 1/2 gt squared. Then substitute 8 meters plus 1/2 the value of gravity negative 9.8 meter per second squared, then t squared. We didn't put the initial velocity of y because we don't have the initial velocity of y. Then compute 8 meters minus 4.9 meter per second squared t squared. Then to get the time, we need to transpose the time, then divide both sides by 4.9 meters per second squared. To 8 meter over 4.9 meter per second squared and 4.9 meter per second squared. Next, cancel out the 4.9 meter per second squared, then proceed to compute this equation. T squared is equals to 1.63 seconds, cancelling out the meter, then second squared. Then we need to square the value, then cancel out the t squared. T is equals to 1.28 seconds. Now we got the time in the air of the object. Now we need to proceed to the value of the distance. To get the distance, we need to use the formula x is equals to initial value of x, then the initial velocity of x times t plus 1/2 acceleration time squared. Since the initial value of x is 0 and there is no acceleration happening in the problem, we only did it to solve the initial velocity of x and t. Vox is 10 meter per second times the time 1.28 seconds. Now compute 10 meter per second times 1.28 seconds is equals to 12.8. Cancel out the seconds, meter. So that's our x, or the distance of the object thrown in the problem.